Okay, so today we're going to push forward with Unit 2. Now we've already started Unit 2, remember. Unit 2, what have we done so far? Well, we've looked at solving simple inequalities, that was review. We reviewed solving compound inequalities, and inequalities, and or compound inequalities. And then most recently we've looked at some weird ones. Some ones where we had to graph the solution first to see, we had to graph the compound inequality, both parts, to see what the solution was. And then we just said that if it's an and, for an and statement to be true, how many of the simple inequalities need to be true? For an and? Both do, right? So we'd be looking for the intersection of the graphs where they overlap. For an or compound inequality, how many of the simple inequalities need to be true? How many statements? Only one of them does, right? So we'd look every place on the graph where either one of them is graphed would be our solution. Okay. We're moving on today to something different. The last two parts that we have to deal with, and we'll break this up into pieces, the last two parts are solving absolute value equations and eventually absolute value inequalities. Okay, what does that mean? Well, they're just absolute value equations are just equations that have an absolute value expression in them somewhere. Okay, so that's an absolute value equation. So before we even start this, one thing I want to make sure you just remember this. Absolute value expressions are tough. You cannot do normal algebra with absolute value expressions. So we've got a strategy for dealing with this, and what it's going to involve, we'll see the specifics here in a moment, but what it's going to involve is always making a trade. We're going to trade one difficult absolute value equation for two normal simple equations that we know how to solve. Okay, so how do we get there? Well, first of all, let's think about what the absolute value of a number really means. If A is just some number, the absolute value of A is going to be its distance from 0 on a number line. Okay? So for example, if I take the absolute value of 3, the absolute value of 3 is 3, right? How come? Because the number 3 is a distance of 3 from 0 on the number line. What's the absolute value of negative 2? 2. How come? Okay, good, because the point negative 2 is a distance of 2 from 0 on the number line. Notice that distance is always positive. It wouldn't make sense if you went out for a run and somebody said, how far did you run? Oh, I ran -5 miles. That doesn't really make any sense, right? Distance is always positive. So, in other words, if the output of an absolute value is a distance from 0, that can't be negative. It wouldn't make any sense, right? Now, it could be 0. What's the absolute value of 0? 0. Because how far is 0 from 0 on a number line? 0, exactly. So it could be 0 or it could be positive, but it can't be negative. So in math, we say the output of an absolute value is non-negative. It can't be negative, okay? All right, so then this brings us to equations. So what if we have we have an equation here. Notice this equation involves an absolute value. So this is an absolute value equation. The absolute value of x equals 3. Well, when we look for solutions to equations, think what that really means. All we're trying to do is we're trying to find the values of the variable, usually x, that make the equation true, the original equation true. So let's just kind of think our way through this. What's one value of x that I could plug in for x that would make that a true equation? What's one value of x? A value I could plug in for x to make that equation true? 3, couldn't I? Because the absolute value of 3 is 3. Okay. Now we're used to there being one solution, but this time there's 2. What's the other one? -3 would also work, wouldn't it, right? So we get 2 solutions, 3 or -3, because each of those are 3 from 0 on the number line, distance of 3. Okay, so what this tells us then is that absolute value equations are different. Okay, and this is directly from our book. Now I want to explain what this means here. So the absolute value of x, and that's a different looking x. What's different about it? It's capital. It's not our normal lowercase x. So what does that capital X mean? Capital X means it could be some expression that involves a normal x, but that expression might have other parts to it also. For example, capital X could represent 2x minus 3, or it might be negative x plus 7 or something. It involves some expression with a normal x inside it, okay? So if we have an absolute value equation of this form, the absolute value of something involving x's is equal to a number, then here's our strategy. We said we were going to trade the single absolute value equation, which is complicated, for two normal equations. And all we have to do is say, okay, whatever's inside is either going to equal the positive number a, or it could equal the negative number a. Either way, when I take an absolute value of it, I'm going to get positive a, right? Okay, give me thumbs. Does that make sense? Okay. All right, so here's the way I like to write that instead. I think the x's are a little confusing. Instead of using a capital X, I use u. It looks like the variable u, where u is just some function involving x's. A is just some number. And here's how we're going to split that. Whatever's inside the absolute value, notice the absolute value expression is by itself on one side of an equation. So we call that an isolated absolute value. Whatever's inside the isolated absolute value either equals the positive number outside or it equals the negative, the opposite of that number outside. So I get two different equations and I just go solve them individually, but they're going to be simple. Okay? Let's take an example. What about one like this? Okay, what's my value of u this time? Or our book would call it a capital X. Negative 2x minus 6, right? So that's the expression that's inside the absolute values that involves a regular x, regular variable. Okay, one thing I want to make clear here. The absolute value of negative 2 is 2, but does that mean that the absolute value of negative 2x minus 6, that absolute value, is going to make those positive? No, it doesn't. It seems at first like it should, but that's not the point. The point is to find the values of x that make this expression work. The expression that has a coefficient of negative 2 and a negative 6 for a constant inside the absolute value bars. If I change that to a positive 2, for example, wouldn't that impact the values of x that worked in my equation? Wouldn't it? And I want to find the values of x that work there in that equation. So when there's a variable inside the absolute value bars, you do not change any signs inside the absolute value expression, right? We leave it as it is. Okay, what might I do first here? Say it again. Of the absolute value bars, you mean?
Yeah.
What about it? Okay, could I distribute? Good question. Could I distribute? What do you think? Thumbs up or down on that? You're right. Gary, and how come? You're right. What's your instinct telling you here? How come you can't do that? Okay, yeah. Okay, we have to, because remember, let me simplify that. That was a good answer. Let me simplify this a little bit. What did we say before? Does normal algebra work with absolute value bars? No. So we can't do normal stuff like distribute. Can't do it. The stuff that's inside the absolute value bars is off limits. You can't do anything until we trade this for two normal equations. But to get there, to make our trade, what did we have to do? Well, to make our trade for two normal equations, we had to first isolate the absolute value. We needed to get the absolute value expression by itself on one side. Got to get the whole absolute value by itself. Okay, so then we're just going to treat this absolute value as one big, like a variable. What are the two steps to get that by itself? Add 2 and then divide by 4. And how come? Well, because like imagine imagine that, here, I'll just do it right up here. What if I gave you the equation, what if I gave you the equation 4y minus 2 equals 38? How would you isolate? You could all tell me what to do. I've done this, you've been doing this for weeks. You all would tell me the 2 steps in order to isolate y would be add 2 first and then divide by 4, right? Same thing here. This entire absolute value we just treat like a y or something. It's just one big variable. We're trying to isolate that whole thing. So we do the same inverse operations. We're first going to add 2 and then divide by 4. So our first goal when we're solving an absolute value equation, the first part of our strategy is always isolate the absolute value on one side of the equation, right? Okay, so let's do that. Now notice I covered up what's inside and just called it a capital X like our book because it's off limits. Yeah, it doesn't matter, right? We can't do anything in there anyway. So we add 2 and then we divide by 4 and we get the isolated absolute value of something, we don't even care what yet, is equal to 10. Okay, so we just finished part 1. And what was that again? What's our first part of our strategy for solving an absolute value equation? But yeah, in general, what are we trying to do? Isolate the absolute value. There's the first part. Isolate the absolute value. Okay, once we've done that, we'll use our pattern. Now let's remind ourselves about that pattern. What did that pattern say? Well, the pattern just says that whatever's inside, call it an x, either equals the positive outside number or what's inside equals the negative outside number. Or if we write it with a u, same thing. What's inside, u equals a or u equals negative a. It doesn't make any difference whether you use a capital X or a u. It's the same thing. What's inside equals the positive outside or the negative outside. Okay, so then we get to split this, and what's inside either equals negative 10 or positive 10. Doesn't matter which one you write first. Makes no difference. We're just going to get 2 individual solutions, right? Okay, so now we've got oh, we didn't want to do that. Now we can get rid of that big X and we can actually look at what's inside. What's inside is negative 2x minus 6. So that's either going to equal positive 10 or negative 10. Okay, give me thumbs. Make sense? Good. And now we've split our one complicated absolute value function into 2 normal, or one complicated absolute value equation, into 2 normal equations that follow our regular rules of algebra that you know so well. So what would be the 2 steps to solve for x? Add 6, and then divide by negative 2, right? And I'm going to do the same thing to each of these equations. And what do I get? Well, if I add 6, I get negative 10 plus 6 is negative 4. Negative 4 divided by negative 2 is positive 2. Good. And then over here, if I add 6 to 10, I get 16 divided by negative 2 is negative 8. I get my 2 solutions. Okay? So I noticed on the test, a lot of people didn't check their solutions on those equations. And they probably should have, right? So remind me, how do I check my solutions? On Desmos, I plug them into the original, don't I? The original equation. Okay, so let's do that. Remember these, our solutions are 2 and negative 8. So let's go up and try that. And remind ourselves how this all works. Okay, so what did I do in Desmos to check? Okay, so f of f of x equals what? Okay, left side of the equation, whatever expression is on the left. So everything on the left in my original equation. So 4 times the absolute value. Okay, so now how do I create absolute value bars in Desmos? It's right there, that A button, right? That would work. I can do that. Or the other thing you can do is you can take a keyboard shortcut. If you hit Shift \, which is right above the Enter key, it creates a vertical bar, which Desmos is smart enough to know, oh, okay, they want absolute value bars, so it creates 2. And then inside I'd have my negative 2x minus 6. I'll hit the right arrow to get out of the bars, minus 2. Make sense? Okay, so there's f of x. Now normally I would do g of x equals what's on the right side. Do I need to do that here? No, how come? Yeah, I already know what's on the right side. It's the number 38. So I just have to see if my solutions give me 38 on the left side of the equation too. Okay, so one of them was 2, right? F of 2, 38. What do you know? F of the other one was negative 8. F of negative 8, 38. What do you know? Okay, so what's that tell us? They're correct. Yep. Okay, so they work. We saw that they worked. Now, so I'll tell you something here. Anytime you have an isolated absolute value equal to a number, your solutions, you're always going to get 2 solutions. Okay, but it still might be worthwhile checking them just to make sure you didn't make some algebra mistake somewhere, right? Okay, why don't you guys try one of these? Go to the boards and solve this absolute value equation. What do we do first? Okay, but I don't want specifics yet. What's our goal? Isolate the absolute value. What are the 2 steps to accomplish that? Good. Subtract 11 and then divide by 2. Perfect. Okay, so let's do that. We're going to subtract 11, and that all look good. Then I get 2 times the absolute value of 2x minus 20 equals 68, right? And then we divide it by 2. And all of this stuff is fine because all the algebra we're doing is outside of the absolute value bars, right? That's okay. We just can't do any algebra inside. So those guys cancel. And I get the absolute value of 2x minus 20 equals 68 over 2 is 34. Can I go further with my absolute value bars? I can't, right? Because wouldn't my next step be, if I'm isolating x, be to add 20 to both sides? Right? But I can't do that because that's inside absolute value bars. So now what do I have to do now? First step was isolate the absolute values. Got it. What's next? Good. Okay, now I'm going to, next part. Part 1 is isolate the absolute value. Part 2 is split into 2 regular equations. And then part 3 is just solve them. It's easy. Okay? So I'm going to get whatever's inside, which is 2x minus 20, either equals positive 34 or negative 34. Okay? Part 2, I split it. Now solve them. Piece of cake. What would the last 2 steps be to isolate x in each equation? Add 20, divide by 2. We got it. And if we do that, I get 2x equals 54, so x equals 27. 2x equals negative 14, so x equals negative 7. I got two solutions, right? And that's normal. I should expect to get two solutions, right? Normally. Okay, how about this one? Walk me through this one. What do I do first? Add 11, okay, because I'm trying to isolate the absolute value. So that gives me 2 times the absolute value of 3x plus 6 equals 0. Okay? People panic. 0 is just a number. It's okay. We just keep going. Then we divide by 2, right? Okay, so what's 0 divided by 2? 0. All right. So we get the absolute value of 3x plus 6 equals 0. Okay, so this time, though, splitting it doesn't really do anything, does it? Because is 0 positive or negative? No. I mean, negative 0 just means 0, right? So I only get one. When I try to split this, I get the same equation twice, so I only get one equation in this case. I just get the equation 3x plus 6 equals 0, which I solve. And last two steps, subtract 6, divide by 3. What's that going to give me if I solve that? X equals negative 2. Right? If I subtract 6 and divide by 3, I only get one solution. And that's okay. In this case, I just got one solution. Sometimes that could happen. Okay, last one for today. Okay, what about this guy? Add 1. I agree. Okay, so we add 1 to both sides. I get 3 times the absolute value of 2x minus 1 equals negative 6. Now what? Divide by 3. And that gives me absolute value of 2x minus 1 equals negative 2. Okay, now what? Okay, split it. Okay, I could do that. I could split this up, and what I'm going to find if I split this, I can already promise you that neither of the two solutions are going to work when I check them. They're both going to fail when I plug them into the original equation. Okay, how could I avoid all that work? There's something here that just gives this away that it's no solution. What is it? Two negative? What do you mean, two negatives? Is that one of your negatives you're talking about? Okay, that one we don't care about. What's the problem, though? Yeah, okay, what did we say earlier about the output of an absolute value? What can it never be? Can't be negative. It could be 0, like our last example, but it can never be negative, right? So what you see here, when you see something like this, okay, you kind of have to be careful about this. When you're solving an absolute value equation, whenever you gotta always have to be on the lookout for this. If I get an isolated absolute value that's equal to a negative number, we automatically know that's impossible. The output of an absolute value could never be negative, right? And so immediately we know it's no solution. We just don't go any further. It's really easy to just skip over that, right? But after a while, after you've done this a few times and you've practiced, you'll catch that, because it feels kind of weird to start with a negative and then, you know, and then split that into -2 and the negative of -2, that seems weird, right? So you automatically know if I get that isolated absolute value on one side and a negative number on the other, no solution, and we're done.